the basics of the gas detector, which is going to work on both our old style gas detector, the Orion, and also the Altair 5X, which is the new style gas detector we have. Both gas detectors, they're laid out the same. There's the LEL, the lower explosive limit, O2, hydrogen sulfide, your H2s, and your carbon monoxide. The only difference between the two detectors is on the new Altair 5X, they're listing this as COM, or short for combustible, so you won't see the LEL indication on there, but it's actually the same thing. So what we'll do is we'll just go through a little description of what each of these, what the limits are on them and where you're going to get into trouble. So we'll start with oxygen here. So oxygen is going to high alarm at 23%, and it's going to low alarm at 19.5%. So to give you a bit of an idea, I think we're at 20.8% in this room right now, the oxygen level. So if we start going north of this, we're getting into increased flammability, can lead to brain damage up that direction. On the low side here, if we start dropping down, we get into the 12% range. Person would go unconscious. 6% range results in death. So oxygen's a pretty serious one. Certain things can displace oxygen and drop your percentage level down. One of the examples of that is methane. And when they did mining, they would use the canary. The canary at 16% would keel over, and that's how they knew they were getting methane displacing the oxygen in the mines. And that's how they knew, give themselves a warning time so they could get out before they got into these really dangerous levels. Moving on, we'll go to the H2s, hydrogen sulfide. So hydrogen sulfide is created from rotting organic materials. So for us, we are alarming at 10 parts per million. To give you an idea, it's lethal at 600 parts per million. You have a short-term exposure limit on this, which is the same, which is 10 parts per million, that you could actually work in that atmosphere for 15 minutes. So you've hit that level, we're going to alarm at that, but it is still, it's not super dangerous, but when you start going north of that, getting up towards your 600, and it's getting worse and worse, it's going to get pretty bad. The example of where we would have had one of these locally was the mushroom farm in Langley. I think, I'm not sure if it was 2 or 3 guys passed away in that one, and that was H2s. Carbon monoxide. So we are alarming at 25 parts per million. The short-term exposure limit, the STEL, on that is 100 parts per million. So once again, you can work for 15 minutes. Time weighted average, so John's in class.
Shooting a video, Doug. I can't edit this out now.
You gotta check your editing software on that. So time weighted average, where was I here? So short-term exposure limit, so 15 minutes you could work at 100 parts per million. You could work 8 hours at 35 parts per million. We would be already alarming though at 25 parts per million on that. So there's a pretty big cushion on that one. I'm not sure where it's at when it gets to the point when it'll kill you, but it's somewhere up and around that range of parts per million. Alright, and the last one, LEL. So lower explosive limit. Let's draw this out here on So this is your upper explosive limit and your lower explosive limit. So each type of gas is going to have an upper explosive limit, and if you go above that, you're getting too rich to burn. If you go below your lower explosive limit, you're too lean to burn. And here's your kind of Goldilocks zone that's just right to burn. So this kind of changes on whatever type of gas you're measuring. Our gas detectors are set off our bump gas, which is pentane. So it's picked pentane, and it's given a lower explosive limit and an upper explosive limit for pentane. And the way they do that on our detector is they take a measurement from here where they give you 0%, which is ground level, and they measure it to the actual lower explosive limit. So in this case on ours, it's going to be pentane. So at this point, they consider this 100%. So starting at 0, going to your lower explosive limit is 100%. They're setting our alarm in here at 10%. So this is our cushion until it gets really bad to the point where it can be explosive. But our alarm is going to go off here, giving us ample time to get out of the way. Where it changes a bit is if you take a different gas. If you take methane, your lower explosive limit might be down here, and your upper explosive limit might move, but we still have that, because of the 10% that is set up, we still have this cushion in here. It might be a little less than it is for pentane, but it's still a pretty significant cushion. So that's pretty much the basics of one other thing on there for the one other feature they've added for the new gas detector is if you've walked in and you're already at the lower explosive limit, it's going to show up automatically on your screen as 3 X's, and that's just telling you to get out immediately. It doesn't want you to spend time to see what that big reading is on there and try to figure out what's going on. You're already in a terrible atmosphere, so it's time to boogie when you see that triple X on there. So that's about it for that.
Alright.
Okay, so I kind of put this one together just to give us an idea of one of the most common calls we go on is natural gas calls. So we often get the call, someone smells natural gas in the area, we go in and we try to investigate and we can't find anything, and we don't get any readings on our gas detector. So I kind of wanted just to put a little drawing together just to kind of explain why that's happening. Mercaptan is the additive that they put in the natural gas so that people can smell it and identify that they have a leak. That can actually be smelled at 1 part per million. So just to give you an idea, at the point when we are going in with our gas detectors aren't going to alarm till we hit that 10% that we explained on the LEL. So at that 10% range, when it equates to on the natural gas percentage here, it works out to 5,000 parts per million. So generally when we go to that call, we are somewhere between the 0 and the 10% here. We're somewhere in very low, and it could be at 100 parts per million. We're obviously smelling the mercaptan, but we wouldn't be getting no reading whatsoever on our gas detector because we're not even picking up a single % on there yet. So this is just showing you the natural gas here. The lower explosive limit is there. That's why it's got its 100%. The alarm levels there is 10%. I've done a conversion over to the how many parts per million it would be, just to give us an idea of the sheer scale of it, why we're not smelling the mercaptan on those natural gas calls. This is our new gas detector, the Altair 5X. They call it the 5X because it's capable of detecting 5 different things. We are running it with 4 different sensors. We won't have the 5th one in there. The 5th one is actually a combo sensor. So we're going to run it as 4, so it's the same as our old style detector. And as we showed you in the previous thing, it's the same setup here of the O2 H2s CO, and you'll see it listed as combustible. So we'll press and hold to turn on. So with this gas detector, there's a little bit of a difference on the setup here. I'll try to talk you through what it's going through on the different stages here, and we will have to block the pump. So here it's asking for a pump test. It's giving you the indication to block this. Okay, so with this gas detector, with our other gas detector even, they're saying that the samples can take approximately 20 seconds to 2 minutes to actually get a sample with your gas detector. So for training wise, for us to get used to, we got to start when we go into a building that you're taking samples in, we got to really slow right down. If you're sampling an area, if you think it's concentrations there, you got to stop by that front door and stop there for 20 seconds plus to get a good, see if you're starting to get a bit of a reading on your gas detector. And a general good rule of thumb is to always get your readings down low first, and then you can move to higher. Most of the gases are heavier than air, so getting our readings low would be the first way to go. And you want to slow it right down, because if we start walking rapidly right through a building, by the time you get to the far side of the building, you could start getting the readings on your detector when you really pick those up by the front door. And if you would have stayed there, you would have known that. Okay, so what we're going to do right now is we're going to add the wand to it. So with adding the wand to it, we're slowing down that detection even more. So we're looking at 2 seconds per foot, so we got a 10-foot cord. So we're slowing down that detection quite a bit. These are quick disconnects, so they just stab in. We'll probably, as soon as I plug this in, this will probably go into alarm because it's starving for air a little bit. It's not used to it. So, which is good. So we will have this on all of them. If we run into setting off alarm, if we pick up any of these indicators on anything, you're going to have to reset the alarm. So if we walk into, we got high CO, we got 45, a reading of 45 parts per million, it's going to set off the alarms just like that on our detector. And the difference between our old one, you could walk outside, get into a clear atmosphere, and it would stop alarming. This one, you'd have to get outside in that clear atmosphere and actually physically hit the reset button to clear that alarm. Otherwise, it'll just keep alarming on you. So now we've got our wand is hooked up. We can do our sampling. So if we're starting low, dropping it down there. This is same as you've done your pump test. If I block this, it would go into alarm. So it's sucking here. So once you're dropping this down, try to get readings if you're doing confined space or something. Obviously, if you stick that tip into the water, it's going to start sucking up water into the system, which we don't want to have, but could happen. If you do run into that, we do have a couple extra spare filters in the box. You just push and turn, pops off the wand, the filter comes out, you can put a new filter in. Okay. So, you're good.
Yep.
Okay, so for this gas detector, one of the differences is that it has to be charged separately from the bump testing. So this is the charge cord for this gas detector. It just slips into place. Red means it still needs more charging. Once it goes green, it's good to go. If it goes yellow, you've got an error somewhere in the whole system and it'll need to be fixed. So if you run into that, I would just unplug everything, try it all again. If you still run into the yellow light that there's an error, then flag it and bring it to one of your air tech's attention. They've used that kind of lighting system on everything, so it's even on here. So Green is good, red is charging or filling the system. And then yellow is bad again on this thing too, that there's an error in the system if you see this thing light up yellow. So it's a little bit of a different cylinder for bump gas. It's got a bit of a collar on this new one. If you do need the AirTex to order it, I'll show you how to recognize when it needs to be ordered here in a second. But if you're ever putting one in, just make sure your expiry date's still good. There's no sense bump testing it to one that's dead. And you drop it in, you screw it on until this thing lights up green, and you know that it likes it. And then you'll see on here, use my good hand for this, that's your PSI gauge on there. So I think it's, what's it reading, 425 PSI, so we've got a little bit left in this bottle. We're pretty good. Once you get into the yellow on there, let one of the AirTechs know to reorder some, and we'll get another bottle of bump gas in there. So you will have to have the gas detector running when you put it in the bump machine, and then you'll have to test it separately. So you'll put it into bump, you'll wait with it until it bumps successfully, you'll take it back out, and then you can plug it into its plug to get it back up to speed. So the only thing you really need to worry about on here is that your gauge, whether or not you have gas, it should say bump / calibrate on fail. So what we're doing is bump testing, and then if it doesn't pass the bump test, it's going to calibrate itself to see if it can get it to pass. The other, it's not lit up right now. The other cylinder spots on there are for additions. You could add to this and be testing for different types of gas at the same time if you so choose, for bigger like mining style operations. So your gas detector's up and running like normal. You're dropping it in this way onto the little tab, push it forward, and then you're raising it up into that little tube. The light should be flashing red in there, means it's communicating with the machine. Use my hand model hand. So it should start going through. So we should start to get some readings on these pretty quick here.
How long does this calibration usually take?
Usually, I think it's supposed to be about 15 to 20 seconds. Although it seems like it's been done already.
Mm-hmm.
I think the more we use these gas detectors, the better and faster they flow through these things. When they sit on the desk or don't get used like this one, then they seem to be a lot slower and sluggish going through the sensors.
Should have bought a buck selfie stick.
Let's redo this one.
And then 1 hour.
So, if you're keeping that video, John, that one took a ridiculously long time. Most of the time it hasn't taken much more than 20 seconds, but like I said, the more you leave it around and don't use it, it seems to be slower. So it's passed, it's calibrated, so when we take this thing out, it's a bit of a tricky maneuver. You kind of lift up, push it in a bit, and it's going to rotate down. It's got a bit of a weird catch on the bottom there. So, I don't know if you can make it out on the camera there, but where your battery indicator is, there's a little check mark beside it. So that's going to stay on there for 24 hours to tell that it's calibrated. So that helps us a little bit if you're checking it later in the day and you're not sure if the guy before you checked it, you see that check mark, then you know it's good. But generally I think we'll still bump test these every morning so that we know that it's going to last for that 24 hours, so you don't just grab it, have a check mark, and then by the time you go to use it, that check mark's gone. Alright, so that's about it for that. To this, some of the guys had a good idea that it would be good for this one to hang onto your gear a little more locked in, so we've added the carabiner onto it. So clip it onto your belt if you need. Okay, that's it for that section.